Sorry about that interruption. My little guy wanted to be a part of the video. Alright, so beryllium and oxygen have an equal charge. Beryllium has 2 positive, oxygen has 2 negative. So you could crisscross and put the 2's down, but that just makes a complicated molecule, so we can simplify and just say that they're already balanced. 2 positives for every 2 negatives, so we just write that as BeO. Over here we've got polyatomic ions. Remember that these are going to be in parentheses. You'll find them on your green sheet. I've also written in the charge here for you. So NO3, nitrate, has a 2 negative charge. Magnesium has a 2 positive charge. So those two are balanced. You just write MgNO3. Here we've got a 1 plus charge on ammonium and a 2 minus charge on the carbonate. So the 2 goes over here after the parenthesis on ammonium. So NH4, 2 of those, so 2 ammonium molecules for every 1 molecule of carbonate. So for the next examples, these are kind of fun. If you don't know the oxidation number, you can figure it out by looking at what it's bonded to, because we know the total charge has to be neutral, has to be completely balanced. So you can do a reverse crisscross like I've shown you here. So you know that this has a 3 charge, this has a 2 charge, positives first, negative is second, so you know the charge is based on that. Or if you go over here, you can look it up on the periodic table. You know that oxygen has a 2 minus charge, so the 2 went there, and then the 3 must have come from the J, so 3 plus, 2 negative. That's the only way that we could have a balanced molecule. Then, for aluminum, J, you know that aluminum has a 3 plus charge, so J, for them to be completely balanced without adding any subscripts, any little numbers, that means that J has to be a 3 minus charge. Carbonate has a charge of 2 minus, so the J has to have a charge of 2 plus, because they're balanced without any subscripts. Alright, naming. N2 is nitrogen. It's one of those diatomic molecules, and there's nothing else to it. Tetraphosphorus pentasulfide. Tetra is from the 4, penta comes from the 5. First one is phosphorus, second one is sulfide. You just use your naming flowchart for that one. This one, there's an imaginary number 1 there after the selenium, but we don't use the prefix mono if it's on the first element. So this is just selenium, and then 6 fluorides means hexafluoride. This one, there's 2 borons, and then 4 chlorides, so it's diboron tetrachloride. So if you're given a covalent name and you're trying to figure out the formula, charges don't matter. You just have to look at the prefixes. So phosphorus, you could say monophosphorus. If it said di, you'd know there were 2, but as long as it just says phosphorus, you know that there's 1. Trichloride means that you've got PCl3. Dinitrogen tells you that there's going to be 2 nitrogens. Monosulfide means that there's 1, so N2S. Bromine, family 17, it's always diatomic. That means it's just going to be Br2. Let's do the ionic compounds next. MgO. For ionic compounds, you name the first one, name the second one, add an IDE ending. So magnesium oxide, lithium hydride. I know you might want to try and do like hydrogenide. It just sounds awkward, so we call it hydride. H2, and then SO4 is in parentheses, so you're going to want to look that up on your polyatomic ion sheet, that green sheet. And SO4 is called sulfate, so we hydrogen first, name the first one, and then the second one we name the polyatomic ion, without adding any kind of IDE ending. Next one, we're going to name both polyatomic ions without any change to the name. So this one's ammonium on your chart, this one's phosphate, total molecule ammonium phosphate. When you're writing formulas for ionic compound, charges do matter. So potassium has a +1 charge, oxygen has a 2 minus charge. This is when you do the crisscross and get K2O. I'll leave the rest for you guys to figure out. We've done lots of practice with this in class. Last little things, how many atoms of each element are present? The 2 right here after the lithium means that there are 2 lithiums. There's 1 carbon, 3 oxygen, so 2, 1, 3. Pretty self-explanatory, same here. 3 coppers, 1 phosphorus, 4 oxygens. But what do you do if you have a parenthesis with a subscript after it? It means that you multiply everything inside the parenthesis, but just inside. So there's only 1 aluminum. This little 3 at the very end doesn't apply to it. Just applies to what's inside the brackets. So we're going to take, there was 1 sulfur, we're going to multiply it by 3. So now we have 3 sulfurs. There were 3 oxygens. Multiply it by 3. Now we have 9 oxygens. If you guys have any questions, go ahead and let me know. See you tomorrow.